What I have here is four-way switching. Four-way switching is about as complex as three-way switching is, which actually is pretty simple. You have one three-way switch here, a three-way switch here, and a four-way switch in the middle. Now from the three-way switch, I'm using 48 volts AC power. That power comes into the darker colored terminal. Terminals are color coded. The two lighter colored terminals are going to send out what are called traveler wires. Those traveler wires are both going to land on the top of the switch. Now this four-way switch will connect either straight across on the terminals or crisscross on the terminals. Okay, so there's your connection. From the bottom side of this switch, the two wires go out to the next three-way switch on the lighter colored terminals. The darker colored terminal sends power out back to the load, in this case a light. Now how this switch works is I can turn on that load from virtually any location. So no matter what I do, I can operate the load from just about any location. You see this in a lot of areas, large areas. Office complexes, manufacturing, large areas where you can control the same lighting from several different locations. With three-way switching, you could only control from two locations, but you could add as many four-way switches as you need into the circuit to control for as many locations as you want. So four-way switching, again, kind of common in industry, not exactly that complex. The big key with all this stuff is you got to hook it up correctly. This is why all the terminals are color coded. Three-way switch, darker terminal is power going in or power going out. The lighter two terminals are going to be connecting what are called traveler wires. These two wires right there are going to go in between all the switches. So four-way switching.